Hello, I'm Chigger, and the date is July 29th, about 6 p.m. in the evening, and I'm going to be taking a little tour here to try to troubleshoot the problem with a trace charge controller that's blown up twice in the last couple of weeks. This shot here shows the trenched in 4-inch pipe that 3,000 foot of penstock that comes in and provides the thrust for the two hydroelectrics we're about to examine. 4-inch pipe coming in here, 2-inch pipe coming over by the hydroelectric. The tower there is like a sediment tower to provide for our drinking water, and now we'll go look at the hydroelectric. Everything kind of messy right now as usual. Not quite done with the installation here, but here's the Harris hydroelectric, and right behind the Harris is the Canyon Industries hydroelectric, which is currently just in standby, not running. Step up this. There's a jumper switch, which you can see right here, which is currently engaged, which allows electricity to go to either of two circuits, which I'll be explaining. Current output right now is about 30 amps, and it's 30 amps with just 3 of the 4 nozzles engaged. You can see ground on the far side there, not quite in focus, and positive on the near side. The positive side goes right over to that little jumper night switch, whereupon copper wire goes through that little ammeter up to two 40 amp fuses. The ammeter on the right hand side there is for the second circuit, which is now not engaged as a load controller, even though that little jumper switch is thrown. And this is the plumbing coming into it. 4-inch going to 3-inch. And the 2-inch servicing the Canyon Industries set, which, as I said, is kind of just in standby right now, not being used. It can be used right at the moment, but it's not being used. Now, the yellow wire closest toward me is the positive pole on that, and that goes over to the red wire just before it enters the fuse box. There's that second circuit I was speaking about that's now not energized at the moment. Ground on the Canyon Industries is this 3 strands of number 10 wire that go out here and then connect to a bunch of wire which I'm about to show you. The ground on the Harris hydroelectric is that 6 strands of number 10 wire that's continuous all the way to where we put the trace flow controller, which we'll see in a minute. Another water tank in here for sediment control of our drinking water. So currently, confirming the ammeter on the Harris, we're running about a little over 30 amps. I'm stepping down. So here's some of the wire coming out of the hydroelectric, which articulates the ground for what becomes the wire going to the trace inverter, which is insulated, and the uninsulated wire, which forms the ground for the other circuit. So they're both jumpered together further along here. The ground on the lower part then would be 6 strands of number 10 wire, and 1 strand of double aught wire, and an insulated strand of what looks like aught wire positive side up here for the circuit, not the Harris circuit, but the other circuit is this double aught uninsulated wire in front of me, and 2 strands of aluminum, looks like double aught wire there, and then the Harris, which supplies the trace load controller, is this 6 strands of number 10 wire, which is carried in two insulated sheaths there. Running a distance of about 120 feet to the shop over there in the distance, and we'll walk over there. The wire on the left is just electric fence to keep the horses from eating the wire. So here's the wiring approaching the messy shop. The ground running low and the positive running high. A little bit of discretion between the two. And this is first battery bank, which is a string of X-sides, I think 1,200 amp hour 2-volt cells, and ground is jumpered here. You see there's a ground from what was coming off of the Harris system, but as we'll see in a second, it's all bussed together. So ground here, and up here is positive. Again, on the negative side of the primary battery bank here, you can see like welding cable running off here to a piece of copper pipe that's in insulation. This other welding cable runs to a ground bus, as does the copper pipe, and I'll follow that along in just a second. The battery connections here are patent and show no variance in voltage. This probably looks like a nightmare to you guys at Trace, but anyway, here's the positive side of that primary battery bank. It's the yellow wire here is thermostat or temperature sensor that was staged right between battery 1 and battery 2 there. The phone wire, which is just lying in a heap on the floor here, is the control wire that goes and was successfully registering the activity of the panel of the of the charge controller over at the cabin. This is right here ground, and it is ground by virtue of the fact that it runs down here and connects with that bus that I was just describing. Somewhat sheltered from view over here, but all bus together. The black wire here comes out of a 40 amp fuse box here. Half of this box fuses the Harris side, and half fuses the Deming, the Canyon Industries hydroelectric. The Canyon Industries hydroelectric runs into this charge controller here. Now, when I throw the switch here, they'll be jumpered together. So I throw the switch, and hopefully no sparks fly out of this guy. And there is a gentle increase in current going into the other circuit, which I'll explain here briefly. This guy got overheated under my application and caused the switch here to have a meltdown, so I had to replace that switch there. You've probably seen these backwoods charge controllers before, and they work pretty good. I've had this one for a couple of years servicing the Trace inverter. Right now, the batteries got so charged up the other day that they're only taking a 2 amp, looks like a 2 amp charge, and the voltage I can read is, doesn't look that high, 24.5. but it's fused over here as well as at the hydroelectric. The ground to me seems absolutely patent, and the black wire then would be what I would call PV, and 3 strands of number 10 wire that run over my head and go in where I'll show you, which services the inverter, which we would call the battery wire. Also, you can see the burn marks over here where the place almost caught on fire due to the charge controller bursting into flame the first time, and actually was hot up the second time to like toast things up a little bit before I could hit that switch right next to it. So this isn't really part of the picture, but I should explain that there are 2 circuits here, and one circuit is the trace inverter. The second circuit is a Vanner 24 volt to 12 volt system that I'll have to describe to you. And this battery bank right here services the Vanner setup and would usually be charged by the by the Deming, the Canyon Industry hydro, except that right now they're jumpered together, so it's getting its energy from the Harris. The solenoid there was coming off of the Trace 4024 inverter. At one point was starting my generator, but I had to come out anyway to like set the choke on the thing, so I kind of gave up on that. I'm going to retreat from that position. I believe I don't really need the generator anymore anyway. So currently I have the relays on the trace servicing some idiot lights that you may be able to see glowing right over that window. I have 2 battery banks that are inside this wall here, and it's vented to the outside and sheltered by a wall from the inverter, or the inverter is sheltered from the battery fumes by those vents and a wall that's built onto it. I'm going to use the idiot lights in connection to run electric gates on the nozzles of the hydroelectric. I've already purchased them and tested it, and it seems like that's going to be a pretty good system. So I'll be controlling, I'll have several different rows of defense. I'd like to get the load charger working, but one avenue of defense is to take one of my relay stations here and jumper that hot. This then is 24 volts coming in from the Harris on the hot side. I don't know if you can see that block right there, but that block there I have to think about this for a second. That block there, I guess, is servicing the Harris system. I'm sorry, the Canyon Industries system. So my idea, maybe I can't show it right here, but my idea is to go directly off the hot side of the Harris system to my diversion loads, which are represented by that little bus there that I'm pointing to, hot water and a heater, a 24 volt hot water and hot water heater. And I have the relay that I'll mount right over here, which will be controlled by the same thing that control these idiot lights up here, which will activate the diversion load at the same time that it would turn off one of the nozzles over at the hydroelectric. So now I'll show you how I have the inverter set up. Example of the gauge of the wire that's carrying 12 volts. The reason it's spliced here is, I guess, when I was digging a drain field here with a shovel, I must have cut the hot side of this big old fat wire, and it just ate itself through, just oxidized itself right into dust, and had to be jumpered like they're spliced like that. A whole gob of number 10 wire that's in sheaths coming over here. 12-volt battery bank over here, a wiring array and tree that my wife really loves. Not. More kind of nightmare wiring there. And then just the control wire that goes inside and gives me all my meter readings, the trace. The instrumentation, pretty primitive, right above the door. And a temporary installation of where I've got the panel for the C40, which is of course now lifeless. And an analog 110 volt meter, which shows a problem there too. Like it's showing about 108 volts, whereas it's 120 volts over at the hydroelectric. I've got a line drop problem there that I'm looking into. I think it's I've got to open up all my boxes, junction boxes, and check for corrosion. I hit the wrong. I hit the back of the inverter now inside little vestibule just outside of the shop. 2 banks of batteries are encased in this shelf here. 8 L16 batteries below, and then 12 CD lead calcium batteries on top that service. The lead calcium batteries are part of that secondary circuit that services the Manor down converter, which in turn goes up to this primitive breaker box here, ammeter and voltmeter that is a point of transmission over to the shop, and also I guess 12 volt applications here in the shop. It goes over to the cabin and also services the shop. This is a point of suspicion right here. This Duro pulse thing kicks out maybe 30 high voltage pulses a second that are right now being fed into the same battery bank, my primary battery bank, and I'm wondering if that could be sending a high message signal that would not register on the charge controller but would account for it not accepting current and overheating. That's a point of suspicion for me. The fuse box, or that little fuse block over there, is what I use for controlling my the bells and whistles on the trace. Another point that deserves attention here, this battery switch is usually mounted on the wall, but it is the hot side of the inverter, which is on the same stud, is the incoming wire from the C40 load controller. In this case it's just jumpered a straight shot from the fuse panel outside. 2 represents the alternative battery bank that's behind this shelf to my left, and 1 represents that primary battery bank outside, the X-sides that I previously mentioned. 110 volts comes out of the inverter, goes into this breaker box over here. One side goes into the shop, the other side goes to an entry panel over at the cabin, which you've already seen by virtue of me not photographing this earlier. One point that I made over there is that I get 110 volts on the trace here, whereas I only get 108 volts over at the cabin, so I've got a line drop issue there I'm going to have to address. I think the you can see the wires coming off the trace. They're very, very large welding cable. I think actually these are the ones that you guys sold, so you'd probably have faith in that particular section of wire. And it runs down here to the ground that we looked out outside, and then the hot side of it runs to that battery switch there, which again on that same stud is the incoming from the load controller, or will be if I get a load controller that works. And on the other 2 studs is battery bank 1 and battery bank 2. The reason I've got the cover over the inverter is because birds make their nest in here, and I'm trying to keep the I think about enclosing it and putting a muffin fan or something on there because I found a nest behind the inverter, some creature coming in and enjoying the warmth of it. It has never particularly overheated, so I'm thinking that some sort of cabinet with ventilation might be the best way to go, a screen cabinet. So anyway, I'd like to get a load controller working on that circuit. I think that it's likely that it's not your engineering that's causing the problem. I would invite your attention to that Durapulse device that I think might be throwing a high voltage signal. I would also ask that you look at my the wiring as I've shown in this video, and maybe you can help me troubleshoot some problems in my wiring. I'm real happy with the trace products I bought in the past, the 2 inverters that is, and it's opened up a lifestyle that we enjoyed before without electricity, but now we're we're more in a suburban setting with the electrical applications that Trace gives us. So we enjoy working with you, and whatever's right in terms of if this is our fault, we'll cover it, but if it's something that might have been predicted by you guys, then I hope that you'd honor the warranty again, and we'll be in touch. Thank you.